Okay, so this is topic 10 and topic 11. Alright, so we're going to combine two lessons into one video. Alright, so we're going to continue talking about limits as x approaches c and c being a number. Okay, so on this one, we're going to talk about different ways to find the limit. Alright, so we're going to do the same thing on the first couple that we did on the last lesson. So, for example, find the limit of f of x where f of x is equal to x minus 5 when x approaches negative 1. Right, so whenever that happens, okay, so to find the limit as x approaches 1 of x minus 5, or you can also write it as the limit as x approaches 1 of f of x, since f of x is that. Okay, so as you do that, all you have to do for this one is a very simple thing. The first thing you should always do is plug in, figure out what f of negative 1 is, in this case negative 1, okay? And I'm sorry, I just realized that said negative 1 right there. So we're finding the limit as x approaches negative 1. Alright, so the first thing we can do is to go ahead and find the y value when x is equal to negative 1. And in this case, that would be equal to negative 1 minus 5, which would be negative 6. So in this case, the limit as x approaches negative 1 of f of x is equal to negative 6. Alright, so that would be the answer for that. Okay, on example 2, we are trying to find the limit of f of x as x approaches 3. So the first step we should try to do is to plug in 3 for x and figure out what the y value is. In this case, it would be 3 over 3 minus 1, which is equal to 3 halves. So if you get a number like that, then that's actually going to be your limit, alright? So the answer would be the limit as x approaches 3, the limit of f of x as x approaches 3 is equal to 3 halves in this case. Alright, so very simple at this point. Now there is sometimes where when you plug it in it may not work. Alright, so for example, let's just quickly look at it. I'm not going to write it down, but I want you to see how this works. Alright, so in this one we're actually going to try to find two different limits. Alright, so this is actually two questions in example 3. So the limit of f of x as x approaches 2, if we plug in a 2 here, alright, on the denominator, we're going to get 0 in the denominator. Alright, so if you can kind of see that ahead of time, and you know that when you plug it in, you're going to get an indeterminate, meaning you're going to have a 0 in the denominator, then you need to do another method. And that method is actually very simple. All you have to do, alright, all you have to do is factor the denominator, and then hopefully something will cancel out. Alright, so in this case you have x minus 2 over x squared minus 4 becomes x minus 2, x plus 2. That's the difference of squares. Okay, so notice that this is going to cancel out, so this is going to be the same thing or equivalent to 1 over x plus 2. Okay, now we can plug x is equal to 2 for this limit. And we can plug in x is equal to negative 2 for that limit. Okay, and then see what happens. Okay, so in this case, the limit, I hate to be writing this much, but you have to write it. This is a mathematical operation. If you don't write that, do not write just f of x is equal to, let me see, actually I don't know what that is. Okay, the limit as x approaches 2, that would mean that I have to plug in a 2 into that equation, so I'm going to get 1 over 4. Alright, so I have 1 over 2 plus 2, which is 4. So this is 1 over 4. So again, do not write just f of x is equal to 1/4, because that's not true. Okay, so you have to write the limit as x approaches 2 of f of x is equal to 1/4. Now on the second part of this, the limit as x approaches negative 2 of f of x is equal to, in this case, I'm going to have 1 over, and notice that I'm using that equation, not that top one, I'm using this one. I have negative 2 plus 2, which is still 1 over 0, so therefore this was the limit as x approaches negative 2 of f of x does not exist. Okay, so that may happen. All right. On example 4, we're going to do the same exact thing. All right. If we plug in a 1, notice that that's always should be the first thing you should try to do, because that's the easiest thing. If I plug in a 1 on this equation, I want to have 1 minus 4 plus 3. So the denominator is also going to be 0. All right, so if that happens, then your next step then you should try to factor the bottom, and hopefully something will cancel out. So we have x and x, so we're looking for factors of 3 that add up to negative 4. They're both negative. So we have 3 and 1. Okay? And then notice that the x minus 1s are going to cancel out, and you're going to have 1 over x minus 3. Okay? Now that you have that, you're going to try to find the limit. So the limit as x approaches 1 of f of x, we're going to plug in a 1 over here. So this is going to be negative 1/2. So the limit as x approaches 1 of f of x is negative 1/2. On the other side, or sorry, in this problem actually, the limit as x approaches 3 of f of x is going to be equal to 1 over 3 minus 3, which is 1 over 0, which means that the limit as x approaches 3 does not exist. Okay? So when you're taking the limit as x approaches a certain value, c, all right, you should always try to plug this in first. Always try that first. Okay? And then now if that doesn't work, then you have two choices. You can factor like I've done here, and then once you factor, then you plug it in. Or also you can do something called multiply by the conjugate. All right, so multiply by the conjugate and then plug it in. Now, I'm going to show you how to multiply by the conjugate. So on the conjugate, when you have something like this, now you might be able to tell that one of these is a difference of squares, but you may not be able to tell, so who knows. All right, so you can actually rewrite this as a difference of squares. All right, and I'm going to show you how to do that in a second, but let me just show you the multiplying by the conjugate. So multiplying by the conjugate, so I'm going to rewrite this original equation here. All right, to multiply by the conjugate, what you're going to do, you're going to look at the denominator or the numerator or the denominator and pick the one that has the square root. All right, notice that the numerator in this case has the square root, so I'm going to pick 3, and instead of writing minus the square root of x, I'm actually going to write a plus square root of x. All right, so I'm going to pick that, plus square root of x. All right, now when you see that, okay, notice that this is completely legal. This would be the same thing as multiplying times 1, okay? And then now what I'm going to do is I'm going to multiply. All right, so I'm going to multiply across here. So I have, let's see, I would have 9 minus x. Notice that I have to FOIL here. If I FOIL here and here, I would have 3 times 3, 3 times the square root of x, negative square root of x times 3, and then finally the square root of x times, the negative square root of x times the square root of x, which got me x. The middle term cancels, so make sure you understand that because you may miss this. On the bottom, well, there's not much I can do. All right, so I'm just going to rewrite that. All right, so I have 9 minus x and 3 plus the square root of x. Okay? So that's what I got at this point, but notice that this can cancel that. All right, so that's why I want to multiply by the conjugate, because now I have something that I can cancel, and that's just going to give me this. And then now I can try to find the limit as x approaches 9 of 1 over 3 plus the square root of x. Alright, and if I plug in a 9 here, that would give me 3, right? 3 plus the square root of 9 is 3. So 1 over 3 plus 3, which would be 1 over 6. Okay, real fast, maybe you recognize it, maybe you don't, but when I see this, I can rewrite that as a difference of squares, where this would be 3 plus 3 minus, and instead of writing x and x, I would actually write the square root of x. So this is just a different way of doing it. Okay, so this is the answer. But if you want to do it a different way by factoring again, you can actually factor the bottom. So 9 minus x is actually this bottom stuff, okay? And you might be able to do it faster than what I did. So at that point, I put that on. So again, I didn't change anything in the numerator, but I did factor 9 minus x into 3 plus the square root of x, 3 minus the square root of x. And then you can cancel this, which will give you 1 over 3 plus the square root of x. And notice that you're back to this part, right? So then now when you plug in the limit, you can get the answer now. Okay. So again, that's how you can get to the same answer, just maybe a little bit faster. All right. On example 6, I'm going to do one more multiplying by the conjugate. Okay, so on this one again, I'm going to pick the one that has the square roots. Let's see. Before I do that, ooh, this one's tricky. Okay, let me see. Okay, so as I look at it, right, I've already see a problem starting to develop that maybe I can take care of later or I can take care of now. But let's, for the sake of, maybe you don't see it now, I can kind of see it happening. Let me just do the conjugate, all right? So I'm going to do the conjugate one more time, and we'll just see what happens. Okay. So let me see. I have 2 minus x over square root of x minus the square root of 2. I'm going to multiply top and bottom by the square root of x plus the square root of 2. Okay. Now on this side, I'm just going to have 2 minus x square root of x plus 2. Sorry, the square root of x plus the square root of 2 over, on this side I'm going to have x minus 2. Okay? Now here's the problem. X minus 2 and 2 minus x are actually different, alright? So I cannot just cancel them because they're not alike, but what I can do is I can factor a negative out of this or a negative out of that, and that would actually make them the same. Alright, so that's what I'm going to do at this point. I'm going to factor out a negative. Let me see, factor out negative out of the top here, and I would have x minus 2. This is going to stay the same. So remember, when I factor a negative, I'm actually just factoring a negative out of this one, not out of both. And if you don't understand that, I can explain that to you later. Okay, so then I have x minus 2 here. Okay, so then that is going to cancel right there. Let me make sure we got everything correct here. Okay, looks like we're okay. So I have negative square root of x minus the square root of 2. And I can try to find the limit at that point. Alright, so we have the limit as x approaches 2. Okay. So this actually will give me, if I plug in a 2 here, that was going to give me the square root of 2, negative square root of 2 minus square root of 2, which is negative 2 square roots of 2. Alright, so that should be your answer there. Okay, so that's that on that. Okay, so now let's go ahead and go to the back. So we're going to do the notes for 11. Alright, so don't worry, your homework is combined. 11 is actually, I think, a little bit easier. So on 11, this is actually one-sided limits. So to do this is actually relatively simple, all right, especially if you have a graph. Now notice that, for example, they're giving you an example here. They're asking the limit is one-sided. Find the limit as x approaches 0. Now that plus means from the right side. All right, so you're going to come from the positive side, and you're going to go this way until you figure out as you approach 0 from the right side, what is the y value? And in this case, the y value is 2. All right, so the notes, again, this little plus means from the right. All right, so again, as the limit as x approaches 0 from the right side, you're coming from the right side, and you're going to go see, you're trying to find out what is the y value as x approaches 0 from the right side, and in this case it's 2. Okay, so notice that if I were to ask you what is the limit as x approaches 0 from the left side, well, that's undefined because there's nothing on the left. Okay, so that's what would happen. So you can only approach this one. You only have a right-sided limit, not a left one. All right, so let's do another example here. Now this is a piecewise defined function. Now I'm going to graph it. You don't have to graph it, but I just want to do it so you can kind of see what's going on instead of me just doing this. And yeah, let's see. We have 1. We have -1. Yeah, that's probably enough. Okay, so this one right here, x plus 1. That means that the y-intercept's at 1 and the slope is up 1 over 1. Okay, so I'm doing something like this. It's a positive slope. Okay, oh, that should be an open dot. Let me put a little bit of okay, so again, that should be an open dot. The reason being is because that's not, you don't have an equal sign here. Right now on the other side, if x is equal to 0 or less than, all right, so I'm going to draw this to the left. I start at -1, but the slope is -1, so it's down 1 over 1, but I can only draw on this side, so I'm going to go up 1 over 1. Okay, so the graph would look something like that. Okay. So hopefully you can tell the picture. Hopefully you can tell ahead of time that there will be, if I ask you for the limit as x approaches 0, it will be undefined because you're approaching two different values. But let's just look at it one side at a time. So we have the limit of f of x as x approaches 0 from the right. All right, so 0 from the right, you can very simply see that this is from the right. But also this is this, right? So if you don't have this graph, you have to know to plug it in here. So if I plug in a 0 here, I get 1, but you can kind of see that already here. Okay, so that's the limit as x approaches 0 from the right side. Now, the limit as x approaches 0 from the left side, all right, coming from this side, is approaching -1. But if you don't have that, again, you can just plug in that 0 back into that x, and you would have -1, which is what we have here. Now, because we're approaching from the right side, I'm approaching 1, and from the left side, I'm approaching -1, I'm approaching two different values. So therefore, the limit as x approaches 0 of f of x does not exist. And I'll write it here for you, but I just said it since it approaches two different values or numbers. Okay? To be precise, you have to converge. You must converge on a single value. And if you're not converging on one single value, then the limit does not exist at that point. Okay? All right, that is it, guys. Ask me more questions tomorrow if you got them. This can be easy to get lost on, so make sure that you really understand this.